The second half of our review, we'll look at questions 16 through 27, the highlighted ones. Again, these are a minimum of what you should take a look at. That will give you the maximum return on your investment, let's put it that way. The other questions it's not will help to review more, but again, even if you do just these, they contain all the things you need to know for the exam. Should be just fine. So we'll start with question 16. Now this is just a counting part, comes from the sets area. So it's not probability. So that's the one thing, is to determine probability is always going to be like a fraction, a part. It's going to be a decimal answer. The probability of something between 0 and 1, 0 and 100%. 100% is equal to 1, that kind of thing. But there's also the set stuff in here where they want the number of items. And so that's exactly what this is asking here, is that it's giving the number in this little n stands for the number of elements, number in A. So set A has 50 elements, set B has 40 elements. The number in A union B is 80. Now if you add 50 and 40, you get 90, so that's not 80, because there could be some overlap. That overlap is what A intersect B is. So the question is, what is that? How many are in that intersection? Now this one, the next one we'll use a Venn diagram, but this one we could use, well, what is the number of A union B is 80. Remember, you can also sort of do this. It works the same way with probabilities, but instead of having numbers, there's percentages. But anyway, A union B is always equal to the number in A plus the number in B, but you have to subtract off the ones that get double counted, because in the intersection, right, here's A, here's B, anything in this intersection gets counted for both A and B, so it gets counted twice. So that's what we're going to do here, A intersect B. So you can do this with an algebraic approach. Replace the numbers. So A union B is 80, we'll put that there. Number in A is 50. Number in B is 40, minus the number in A intersect B. So we can add these together. We get 80 equals 90 minus the number in A intersect B. We could subtract 90 from both sides. We get our negative 10. Well, how could it have negative 10 things? Well, it can't. It's going to be minus n, the number in A intersect B. N is not a variable. It is an instruction. It's an operation, the number in AB. And so this negative is like a negative 1, so we divide both sides by negative 1. That makes that a positive. That makes that a positive. So 10 is the number in A intersect B. But this formula carries over into the same thing in probability. So we do those things. The probability of two events occurring, you have to subtract off the intersection of both of them happening together, because that gets double counted. Okay, so the next one we're going to set it up like that with a Venn diagram. And this one, though, because of the way they gave us the information, they didn't give us the intersection. That would sort of be the harder way to do it with the Venn diagram. Okay, so that's 16. Thanks.